Yeah, well, hi everyone. I'm really glad to be here. Thanks for having me. So as we've seen, this morning we would have an introduction, or morning for me at least. We would have an introduction to Houdini, I think, with the perspective of TouchDesigner users. There's a lot of similar things between TouchDesigner and Houdini, so I think that's a great starting point. If you've not used Houdini before or you've not got that much experience, it's going to be a good way of getting into it. So I guess, first of all, for those that don't know, what is Houdini? It's basically like a 3D software that's a bit different than the traditional C4D, Blender, Maya. It's a node-based software, and it has a lot of stuff in it. You can, build simulations with fluids, pyro, smokes, volume simulations, a lot of visual effects with particles, as well as 3D modeling. So it really has a lot of things in there and a lot of different layers to it. And it can be quite daunting because there's so much in there to learn. But it also really gives you the possibility to make complex stuff in a pretty easy way if you go about it the right way. So I guess to start, if we try comparing a bit to TouchDesigner to see if there's some similarities here or some differences. So the first thing is, a lot of people know this, but they come from the same software initially. They were the same company, I think, and very much the same code base. And they split. And on one hand, we had the SetFX Houdini, and the other hand, TouchDesigner. So they're both node-based. They both work with geometry streams or data streams. You get a stream of information from one node, plug it into another one, get the result, and so on and so forth. And you build your networks and you get your results at the end. They both have the same sort of underlying concept of having the sub context for all your geometry, the top context for your textures. Chop networks also exist in both of them. So they're pretty much built the same way. They offer the same stuff. The big difference is that Houdini is not real-time, or is not aimed to be real-time. It's a lot of pre-render stuff, even though depending on your machine and the simulations you're running, they can run pretty close to real-time in your viewport. On the other hand, TouchDesigner is purely real-time. It's meant for real-time installations, real-time visualizations, a lot of that. So that's one of the big differences to keep in mind as we're building stuff. It's really hard to build stuff in Houdini, which is aimed to be real-time. It's very often you end up having either sending the geometry to another package to render it, or exporting the geometry to use it in another project, or rendering straight from Houdini. So that's a big difference. One of them is real-time, the other isn't. Yeah, so as I said, typically, in Houdini, you're building a lot of simulations with fluids, with particles, with smoke, mostly visual effects. That's the big thing that Houdini offers. Is it's pretty easy to get started with building, for example, soft body simulations, rigid body simulations. Particle systems are super simple. It really offers a lot of stuff that you can get up and running pretty quick. The learning curve is a bit steep because as soon as you leave the simple stuff, it becomes pretty complex. But with the examples we're going to look at here today, you'll see it's fairly simple to get started if you have that node-based background, to get started and get some pretty interesting results pretty quickly, actually. Just one quick disclaimer that we're not going to be covering the topic of rendering, because that's a bit of a different topic. It's different set of nodes, and mostly the reason is that there are lots of different renderers. You have the built-in renderers from Houdini, which are Mantra and Karma, which is a newer one. And then you have Arnold, Redshift, Octane, some others, which I can't remember. So there's a lot of different rendering packages, and everyone has a bit of their own set of nodes, even though they're quite similar, but it's a bit off topic at this point. Yeah. So to get started, if you have Houdini installed, that's great. I'm using the last version, which is Houdini 19. And yep, you should get it up and running. So when you open Houdini, there's a lot of stuff. There's a lot more than there is in TouchDesigner. That's because there's a lot more stuff that can be done with Houdini than TouchDesigner, but we're going to focus on things that are similar and the sort of basics we need there again to get things up and running. So if you check up at the top in the menu bar here, or whatever you call it, there's a drop down here, which lets you select different workspaces, which are all focusing on different layers of Houdini, depending on what you're focusing on. There's a lot of different ones. Today, we're going to use the build one because it's the most basic one. It has everything that we need to get started. It's not so cluttered. So here on the left, you have your viewport where we would see the geometry that we're building. You can, for example, if you hit the D key, you have this, it opens up. And if you go to background, you can click a different color. I just use dark as a default. I think this is the color when you open Houdini, but if you want to change it, that's how you change it. Then what's important, we have down here, we have this part here, which is called the network editor. And when we drop their nodes here on the panel just above, we're going to get parameters. That's like the most basic we need to get started. Having our network here and the parameters up here. Then there's this menu here, which shows you all the different types of networks. And they're fairly similar to TouchDesigner. We have the CH, which is chops, IMG, which is the equivalent of tops. One thing to note is that the top network or comp network in Houdini is much slower than the top network, the top context in TouchDesigner. Then we have mat for materials, which is pretty much the same as TouchDesigner. Object, which is where we're going to be building our geometry, and then out for the rendering and some other things. Shop for building materials as well. So if we stay in the object context, this is where we start to build the scene typically. So this is where you would add your geometry, you would add cameras, lighting. You can also add networks to get materials in this part as well. So this is really where you build the bulk of your scene in terms of like the geometry itself and a bit of the way you're going to render it. So just the same as when you're using TouchDesigner, if you hit the tab menu or like the tab key, sorry, then you get this menu with everything that you can add at this point. The most basic one is if you just type geo for geometry and drop a geo node. This is where the geometry is going to live. So you had your network and you need to add a geo node, and inside of that geo node is where we're going to start building geometry and seeing what happens. Here is also where at the same levels where you put geometry is where you would also add a camera, for example. And then you see it in your viewport. And then if you were to select up here, in this menu here, you can select your camera and you're seeing through the camera. We don't need that at this point. So yeah, I think we can get started and dive in and start building some geometry. So if you dive into your geometry node, this is where you get, again, a clean slate, and you have to build the network here again for any geometry that you want to build. If we hit tab again, we have another tab menu with all the different nodes that are, geometry context. There's a lot of them, as you can see. So there again, like you realize that Houdini has a lot of stuff that can be done, and there's a lot of stuff to learn. But we're just going to go over the basic ones and get something up and running pretty quick. So, I mean, I guess the very first thing is if you hit sphere, SPH, type sphere, you get this sphere in your viewport. Super basic, very first example. If you hover over the viewport where your geometry is and you type the W key on your keyboard, you can toggle between wireframe or shaded. I tend to use wireframe a lot because I find it just much easier to see sometimes what's going on. Okay, so we have our first primitive. We have our first geometry. At this point, what's interesting to see is that when you've dropped down your geometry node, or your sphere node, sorry, then on the panel above, as we mentioned earlier, we have all the parameters. They're again super similar to TouchDesigner. The interactions are the same. If you click here with your middle mouse and then drag, you get this menu that allows to change the radius of the sphere. You can change its position. So very similar things. Change the density of the geometry, the number of primitives you have here. You can make it primitive. You can make it a polygon mesh, up the frequency. Very basic stuff that I'm sure like we've all seen before. So if we cover some important things here in the viewport, we have here on the right of the viewport, we have a bunch of different buttons. Some of them are pretty useful. We have here this little dot, display points, which when you click it, it displays the points within your geometry. If you click the one here with the number, it displays the point numbers. And that's really interesting, to see the order of the points in the geometry. It's going to be useful a bit later on when we work with groups to see what we're working with. You can also display the normals here. If you hit this one, display normals, which is just under the point. So here, a lot of sort of debugging or visualization stuff, which is really interesting to have. The same for the primitives here, if you want their numbers, right? So that's a lot of the really basic stuff that, you tend to work with a lot of those things, just get an idea of the way the geometry is built, to visualize something if, something is going wrong, to debug, really useful stuff. That sort of brings us to another topic. It was like the way the geometry is built. You have your geometry, and in it, that geometry is made up of a bunch of different primitives, which in our case here are those triangles. If we hit this one, which is display primitive numbers, I'll just lower the density here to see a bit better. Yeah, we can see that each of those triangles has a different ID, which is like just the number of that primitive. That primitive is in turn made up of vertices, which themselves connect different points together. You can see all of that if you, up here we have geometry, tree view, material palette, asset browser. We don't need any of those, so we can close them. If you hit this little plus button and go here, inspectors, we get the geometry spreadsheet. That's a super important and super useful thing. It basically gives you it's the same as a DAT. If you're thinking in terms of TouchDesigner, it's really the same as a DAT, where you can, like an info DAT, where you get the information of your geometry. So you have 4 buttons up here, which is a different sort of, what data you're looking at, whether it's the points, then it has, at this point, all the points just have their coordinates X, Y, Z. You have the vertices, which, they each have an identifier of which point they're using. Sorry, just one sec. Yeah. And then you get your primitives, and then what Houdini calls the detail, which is, the mesh itself, like the geometry, which is everything that's in there. And this, just as much as those things on the side here to get more info or more visualization of your mesh, this thing here, you use it all the time. If you want to check or debug something or debug some parameters or some attributes, this is where you go to look at what's happening. Really useful to have. So it really gives you the detail of everything that your mesh is made of. So here we have a sphere, and we can see the content of the geometry. In this case, there's just a bunch of points. One other thing is if you hover over this node, you get different things. This here, where you can disable the geometry, but we only have one in the scene, so it can't be disabled, or like it can't be hidden. Sorry, that's visibility I meant. You can, of course, bypass it. So just the same as TouchDesigner. And here we have the same thing as Touch has. When you sort of middle mouse over a node, you get some information. So you get the number of points, the number of primitives, number of vertices, polygons. It's telling us that we have 1 point attribute, which is a float value, which is exactly what we had here, which is 1 point attribute with a float value, vector float, which is just the positions of the points. And some more useful stuff like the memory that is taking on the disk, in the RAM, total cooks. Just some relevant stuff that, if you're starting to slow down, you can start to look here if you're, maybe building too much geometry or something. So yeah, so we have a first sphere. Then you can, other super simple things. You can bring a box down, and that's just another type of geometry, which is the same as TouchDesigner. And here again, if you want to make it visible, you click this little eye symbol here, or this button on the end, and it will toggle between your geometries. If we bring, say, like a torus, for example, there again, you can display either of them. You could bring down a merge node here, and that's going to let you merge different geometries all together. And you would end up, if I disable this, with all of the geometries here displayed at the same time, even though they're all turned off here. We've merged all of the geometries here, and we can see everything. One other thing. No, sorry, we'll cover that later. So that's like the super basic stuff. You can bring down geometries and start building them. Another important one, which is very basic, is a transform. So then you connect them like this, exactly the same way you would work in TouchDesigner. And you have to always display the last node in your node tree if that's what you want to get. If I start modifying this here, translating, but I'm visualizing the other one, then I won't see what's happening. I would have to go back here, and then, I will, oops, sorry, the wrong one. Here, I'll start to see working with that node. So just the same as TouchDesigner, you can, work a lot with those values here if you start changing this stuff. And that's like the way I work all the time in TouchDesigner. I never sort of use the viewports because it's not got all those tools here that allows us to change stuff. For example, if you click this one here, oh yeah, so there you're like selecting the node itself. You're affecting the transform here by using this like viewport gizmo. This stuff is a lot like Unreal or Unity, if you've ever used them. It's just like basic modeling stuff. You can just move your sphere in the viewport, rotate it. This is sphere, so I can't see rotation, but very basic 3D editing or modeling tools. When you're in this selection mode here, to quit it, you just press escape, and it toggles back to your just like viewport visualization. If you're shifting something around and you want to sort of move your camera without moving the object itself, you just hit Alt on Windows, at least. I'm not sure what it is on Mac. And then you can just shift your camera, and then when you release Alt, you go back straight to your editing mode. Yeah, so that's super simple. Just basic stuff, bringing some geometry and adding some transform to it. Then again, back here, if we merge, highlight this one, and we start playing around here. You've modified this geometry stream, but not the others. Okay, so that's like really simple stuff. from here, I mean, there's a lot of stuff that can be done if we delete this. I mean, I had some examples in the files that I gave. Like one of them was if we build something slightly more advanced. So we have a sphere here. I'm going to go back to wireframe. Yeah, just the same as TouchDesigner again, you have different primitive types. You have a lot more here, but you have the basic ones, which is primitive, polygons, which gives you this sort of geosphere, or like the polygon mesh. I always prefer working with this one. If we bring up the frequency, we just add in more geometry. And something super simple, we can, it's pretty much super easy to do in Houdini, and a lot of people are using in TouchDesigner, is just add noise to the surface of geometry. So we have this mountain node, which is super simple, just adds noise to the surface. And you have a lot of different settings. So you can zero center your noise, you can make noise positive, all of those. The zero center is, at least in my opinion, always easier to work with. There you have your noise types, which is, again, super basic stuff. Simplex, yeah. Element size, which sort of gives you the, just like any sort of Perlin noise. If you're thinking TouchDesigner, this would be the period. If I'm not, like, if you're using a noise chop, like this is a period. So yeah, super simple. We've just made a very basic example of something that gets done a lot. There again, if you go back to your sphere, if you up the resolution, then you get something a bit cleaner. And it has the same concepts of, there again, like an offset, for example, which is when you're using the noise top in a noise chop, I don't remember, at least a noise top, you can go to the transform tab and add some transformations and start like, shifting the noise over time. One thing to note is that there's like a lot of parameters that you can work with in Houdini, and you can add expressions here, just the same as in TouchDesigner, where you have for example, like me.frame.time or time.frame, or like absolute time.seconds. Here you could say, for example, $FF corresponds to the current frame. So one big difference also that I didn't mention is that in TouchDesigner, it sort of has a timeline, but it's not connected to that per se. You would have to, you can just use absolute time.seconds and then something will run forever. In Houdini, everything you're working with is connected to this timeline. So it gets to the end and it wraps back to zero. It's like not the same. So there is no sort of absolute time.seconds. You would have to get either use the number of seconds from the timeline or the number of frames from the timeline. And that's what, you can start working with to animate stuff. So here in this offset for my noise, I just hit $FF, which is the float frame number. If you hit $F, it's just like the frame number as an integer. If you're using $FF, it's a float value. And then you could say multiply it by 0.1. And so every frame, we're going to get a different number here, and it's going to offset my noise. So if the timeline, if you hit the up key on your like arrow keys, the key is like the arrow up, that starts the animation. You can also scrub through with your mouse, of course. So that's super fast. If we reduce it even more and hit the up key again, okay, we've just like within 2 nodes, we've just like made this super easy animation of a noise on a sphere. You could then, I think, in my examples, check. Yeah, another thing that I used a lot in TouchDesigner as well, but it just doesn't work so well, is the Boolean operator. What the Boolean allows is to take one geometry and subtract it from the other geometry, for example. So if we build a box, drop down a box, we can highlight this. there again, you start to notice that when you highlight one object, you're hiding the other one, which isn't always easy to work with. If you hit the other button here that's next to the visibility one, you ghost it. So it allows you to see just like a ghosted version of another geometry scheme that you may be working against. In this case, we have a sphere that we've just made with some noise. If I want to, for example, make a box that's going to be subtracted to that geometry, I need to see the other one. So if you hit that button here, which is just next to it, it allows you to see a ghosted version of the geometry. Okay, so if we bring a transform here and we highlight the transform, we're going to be able to sort of, for example, make the box smaller. If we use this tool here in the viewport, bring it up, for example, okay. There again, if you're in your edit mode and you want to turn the camera without turning the box itself or affecting the transformation of the box, just hit your Alt key. Okay, so we have a box that's standing just on top of this sphere and they're intersecting. They're not connected though. I mean, you see if you highlight the sphere with a noise on it, you don't get the box. If you highlight the box, you don't get the sphere. So we could use a merge node, for example, and this, if you connect both of them, input both of those streams into the merge node, you're going to get them together. But we want, for example, to say like, we want to create a negative space where the box is on the sphere. You would have to use a Boolean operator. So that allows you to make Boolean operations directly on your geometry. So for example, as I'm saying, in this case, what we're going to, there we go, we have it. If you just highlight the Boolean operator, then it's subtracted here. You can see in the parameters for your Boolean operator, in the output geometry operation, it has a bunch of different ones. The subtract here is taking A and subtracting it to B. Or no, sorry, it's subtracting B to A, so A minus B. So the A stream is this one, which was our noise sphere, and the B stream is just a box we have. So if we connect them together, we basically have the noise sphere that has had the box subtracted to it. So it just basically cuts the geometry on the sphere and just uses the box here that we created. It just uses that as like a shape, but then it doesn't output that one. And there again, if you run the timeline, we have exactly the same thing, but we've subtracted the box geometry from it. So that can, I mean, that's just a very basic example of merging, like not merging, but having different streams together and compositing them, I guess, in a way. Super simple stuff. There again, like I've done some of that in TouchDesigner and it doesn't always work that well. I think basically like the subcontext of TouchDesigner is a bit old and it's not always super efficient. In Houdini, like everything works really well. Okay, so I mean, these are the basic things to get started. You have like building primitives to get some geometry, adding some transformations to them to make them smaller, shift them somewhere else in the scene, sorry. Deforming them with some noise pattern here with the mountain saw, cutting stuff with the Boolean, for example. You could also clip geometry, which basically creates a clipping plane, that then it cuts that geometry here. You can change some stuff here, change the direction of the clipping plane if you want to clip on a different axis. So really simple stuff. You have all of those here, like a lot of them are in the manipulate, which work on the geometry. You can twist geometry, bend it. There's a lot of stuff. There's really a lot of stuff in here. So that's really the basics of starting to work with geometry. What else do we have? Okay, so another thing that we can look at, which is super simple to build, which is a lot of people ask for that in TouchDesigner, is instancing. So if we build, for example, like a sphere, there again, we get a sphere in the scene, missing, just reduce the scale by a lot. We end up with this, we end up with this really small sphere. Very often, you want to work with a lot more geometries than just like one sphere in your scene. And it's the concept of instancing, I guess, if you're comparing to TouchDesigner. So if you're to drop a grid, because if we're instancing geometry, we need to instance it onto something. We need some other positions or information as to where we're going to display all those instances. So if we drop a grid and highlight that, okay, you get this massive grid. If we reduce the size here, because we don't need to be that big, it's just put this grid in the middle of our scene. And there again, we have a tiny sphere or this grid with some geometries on it. If we toggle to wireframe, you can see a better view of it. Houdini has like probably the best node, which is the scatter node, which was, I think, recently added to TouchDesigner as a sprinkle node, which basically takes a surface or a geometry and scatters a bunch of points over it. The difference, I think, between the one with TouchDesigner is that this one actually relaxes the points, which means it just distributes them without intersection. There again, a lot of parameters in this one. You can have the number of points you want. So if you start dragging this down, you get less and less points or more and more points. And if we go to the bottom here is where you get the big difference with TouchDesigners. You have the relaxed iterations. If you uncheck this, it just randomly scatters them on the surface. If you check this, it makes this sort of nice uniform scattering, and you have no intersections. Yeah. So Houdini has another very useful node, which is copy to points here, which lets us take, it has two inputs. It lets us take the geometry that we want to copy and the target points that we're copying on. So if we connect our sphere here, and on the other hand, we still have this one highlighted, which is the scatter, which is basically those points scattered over the grid, and you connect them both, it basically very quickly just like scatters your points. Instances are like copies this sphere over to each one of those points. If you make a box, for example, here, again, if we lower the radius, lower something like that, and switch out the sphere with a box, there again, it's just instantly copied us. Something to note is that in this case, we're not exactly using instancing. This is actually copying the geometry. So the copy to points is taking the sphere and it's copying that geometry over to all the other points we have. If we click on copy to points and look at the parameters here, we have something towards the top called pack and instance. And in this case, if you hit this one, it instances the points. The one way of seeing that is if you hover the copy to points and go to this information tab here, you see the memory here is like, okay, 300 KB. If you uncheck pack and instance and go back here, we're now at 15 megs. We've copied like, it was like 616 copies of this sphere. So this takes up a lot more space in memory. It's like 16 megs of memory because we've literally copied that geometry 600 times. If we click pack an instance, there's only one copy of that sphere, and then it's instanced all over the other points. Exactly like when in TouchDesigner you're building that sort of geometry workflow where you have the geometry incoming, some geometry data incoming into geometry node, and then you have your instance tab, and you've got maybe like a top or a sop or a chop with the point information of where you're instancing your geometry on. You get that if you hit the pack and instance. Okay. So I guess we could build something here that's a bit more interesting than just copying some spheres, and it's sort of going to be, actually, no, there again, we'll get to that later. So to get, to move on, there's a really important concept in what's it called, sorry, in Houdini, which is attributes. We have that as well in TouchDesigner. In Houdini, it's like a really important thing. In TouchDesigner, you can get along without ever using them. It's the concept of attributes. So if I go on my sphere here and I go back to the geometry spreadsheet we had, which if you've closed it, it's in panel inspectors, geometry spreadsheet. We have, in this case, we're just looking at this sphere that we have. All it has as an attribute so far is just like a vector position for each one of the points. If we drop, for example, an attribute create, that is going to let us create an attribute at a different level of the geometry. So to explain what that means is if you get here, so you have a lot of stuff. Important one here is the name. So I don't call it my ATTR is like my attribute. And at this point, class is what I was meaning by level of geometries. Either it's living on the vertex, on the point primitive, or on the mesh itself as a whole. So if we keep working with points, we have an attribute called my ATTR that's on the points, that is of a type float, and of a size 1, which means just like one floating number. And then you have the default value, which we can leave at 0. And for example, like the value that we wanted to have is 1. If you go back to there to the geometry spreadsheet, you see that we've just created this new attribute. That's like, as I say, like a very important part. If you want to, for example, make something more concrete, there's a built-in attribute on the geometry. There are a few, like there's like P, there's P for the position, there's N for the normal. Like CD as an uppercase C and lowercase d is the color. And that's going to be, we can make it on the points, for example. It's a vector because we have RGB. And there we see like it's kept the value I had before, which is 1 on the red channel. And if we add 1 here and 1 here, we get white. If you know, that's basically just like a color attribute. And that there again lives on the geometry. So in our case, it's just another point attribute. If we make a box, for example, here and make another attribute create, let's highlight that one. So now we're on the box. Just actually up the scale of the sphere. Again, we can call it CD. It's a point attribute. It's vector type, and say make it, I don't know, blue, sorry. There again, we have both. This one white. We have two different geometries with the same sets of attributes. If we look at selecting the attribute create for the box and we look here, we have the same thing. We have the position attributes and then a CD attribute for the color. And we had exactly the same one on the sphere, but a different value. So the attributes like essentially allow you to store information at different levels. For example, we could put that on the primitives. It's not going to change much in this case, but if you go back to geometry spreadsheet, on both of the geometries here, I've just switched it from being a point class to primitive. So if we go back to the geo spreadsheet here, for example, on the sphere, or here, like you can see at the top, like there's those 4 buttons here. We've still got the point context, so to speak, but the attribute is gone because we've just moved it over to the primitives, which is here. It's that one here. It's the 3rd one along. So now the color is actually living on the primitives as opposed to be living on the points. There's another one which is built in, or like very important at least. I've deleted everything. If we make another network here, say again, start with a sphere, lower the radius to something super low. Again, create a grid. So we have different geometries here. We have this massive grid. We can lower the size of the grid up here. Again, drop a scatter node under the grid, which is going to scatter the points all over this grid here. And use the copy to points we saw earlier again, and that lets us copy all those spheres to the different points on our grid. One thing we can do with attributes, for example, there's another one called p-scale, which is going to be like a uniform scale of your mesh. So if we drop an attribute randomize, this is going to let us take an attribute and randomize its values. So at this point, we're working on the scatter node. We've scattered a bunch of points on them, which is just like a point in space. If we check the geometry spreadsheet for the scatter, we just have this, nothing else in those. We just have point positions. There, by default, when you drop an attribute randomize, it just randomizes the colors. But if we randomize here, the attribute randomize looks very much like the attribute create. It's got like the same sort of fields in it. If we go back to the randomize, it's going to ask for an attribute name, the name of the attribute we want to randomize. So if you type p-scale, it's going to randomize this attribute here, p-scale, which at this point you don't see anything happening because it's just a point in space. It doesn't have like volume. P-scale is a float, so it's a dimension of 1, and it's going to go from between 0 and 1. So if we want to say like minimum value 0.1, maximum value 1, what happens here when you use the copy to points is that it actually, so it takes your sphere geometry and it copies it to each one of the points that we had scattered on the grid. It also copies over the attributes. So each one of the points, the attributes get copied over to the sphere. So in this case, in the attribute randomize, we took something called p-scale and we set it, it's a float, so it's a 1 dimension. And we gave it a value between 0 and 1. So we've asked it to randomize the attribute p-scale between 0 and 1. And that copies it over to the sphere. And basically p-scale is, a uniform scale of your mesh. So we've just copied the sphere over and randomized the size of that mesh. If we go back here to the attribute randomize and check the geometry spreadsheet, you can see that there's a p-scale attribute which has, there again, a random value between 0.1 and 1. You can sort them if you click on the name of the attribute. There again, sort for the minimum and the maximum. So that's another important thing. Like, it copies over the attributes, and that's like one way of starting to play around with, getting interesting results. If we disable this by clicking on this green arrow, all the spheres have the same size. If we enable it, they copy over the p-scale attribute and change size. If we drop another attribute randomize under that, and we don't touch anything on it, it's just by default always on the color. There again, it copies over in our stream of points here. It copies the color attribute over to the sphere, and we just end up with random colored, random sized spheres. So attributes is a pretty important concept. It really lets you store a lot of different things on the geometry, and you can use that for a bunch of different effects. It's really important to use. I mean, you can't really live without it, as opposed to TouchDesigner, where you create normals or tangents, and that's pretty much it. Or if you're doing something more advanced, you'll use them, but it's not so common. Yeah, another important concept that we have is the concept of groups. So that exists as well in TouchDesigner, but there again, I haven't used it that much. So groups allow you to, if you have a geometry, it allows you to take a subset of that and then apply something, only to that group. So if we drop, for example, a torus, okay, for a chain. So we have a torus on our network, we'll highlight this and we get a torus here. Let's say we want, I don't know, we want to delete or we want to add a transform, like a scale, for example, only to some of the, to 1/2 of the mesh. So you could drop down a group node, and that's going to allow us to select a subset of this geometry and then to apply something just to that subset there. By default, it selects the primitives and it selects all of them. Let's go with points, for example. And then you have different mods. So you have like the base group, which is, you can specify here, for example, if you type 0, it's going to take, let's highlight the point numbers here. If you hit 0 here, it's just going to take like 0.0. If you, type 40, it would take 0.40. And it would create a group with just that one point. You can also, I don't remember exactly the syntax, but if you type like 0 to 10, for example, with that syntax there, I don't use it that much. It's going to select like the points 0 and 10 inclusive. We don't want to use this in this case. There are other modes like keep in bounding regions or normals or include by edges. If we go and keep in bounding regions, it creates this bounding box or bounding sphere, which lets you, you can drag this around here with selecting the transformation tool here in the viewport. It lets you can change the size, and it lets you basically keep the points which are in that volume. So, I mean, you can make any sort of selection of points here. And you name your group here. So by default, my GRP, for example. So you have now, we're creating a group of points, which is called my group. And so far it does nothing. It's just in memory here. If we check the geo spreadsheet, again, on the point level, we've just now created this one here, which is a group called my group, and all the points that are in it are going to be highlighted in orange, or have value of 0 in this group column here. If we, for example, then you drop a transform node. If you start transforming it like up the scale, sorry, it goes to this one. We're actually scaling the entire mesh, which is not exactly what we wanted. We created a group just to transform only the points from that group there. At the top of most of the nodes in Houdini, you have this group parameter here, which contains the groups that have been created previous to that node and lets you work only on those ones. So if we take my group here, we can kill the point numbers here and change the uniform scale. We're now scaling only the points that we actually had selected here in my group, which are the orange ones, highlighted in orange. And we go back to the transform. We're working only on this group of points. If we go back to this node, if you want, for example, we can drop a blast node, which allows us to blast away some geometry, and connect that. If we highlight that, it's blasted everything. There again, at the top, we have this group node, our group parameters are, and if we drop that down and select my group, it's going to delete only the points in that group. If you want to invert it, delete non-selected, and sorry, these were the points that we had in the bounding box we're going to keep. Yeah, so there again, groups, it allows you to select a subset of your geometry and apply some subsequent operations only to that group. Pretty useful. I mean, used a lot. So let me check my notes. So I guess we can see like a bit more of sort of in-depth example using groups, which is kind of interesting. And then I guess we can move on to building something a bit more complex, because that will allow us to see a lot of those concepts, the attributes of groups, just basically like node, like building networks. It'll be more fun than just going over every different node in Houdini. Okay, so I'll go back to my base level and make this geometry hidden and create another geometry node. And I'll dive into that. So we're going to build a very simple cloth simulation. There again, you'll see like building cloth in Houdini is like really simple for like basic examples. And we'll use what we just saw there with the groups and make something where we have a cloth that's got some points that are pinned and some that are not. So some points will drop with the cloth simulation, and the pinned points that we've selected will always be fixed. Okay, so dropped in a grid. Again, reduce the size because it's ridiculously big. If you lower the rows and columns here to make 2 of them, you get this box or quad. Then we can use a remesh node, which is basically allows you to take an incoming geometry and remesh it with a pretty uniform size of polygons. So if you hit the remesh node, we instantly get a bunch of triangles that get built. It also works better with simulations to have this sort of planar patch as opposed to having like a grid which is just made up of a bunch of quads. You would need like a really high resolution, and this here tends to look better in terms of results. The remesh node has a bunch of parameters. Like the most important ones are here, like the iterations and the smoothing. So iterations is the number of times it runs this remeshing, and smoothing is, yeah, it's the smoothing out. Pretty straightforward. And then the element size. The element size is what allows you to give the remesh node the target size for each polygon you want. If you're going super low with this number here, be careful, because I mean, it gets super dense, and number one, your simulation will be slower when we make the cloth simulation. And also, yeah, at one point it takes like, if you go really low, it creates a lot of geometry and it can slow the computer down. Okay, so if we highlight the point numbers here with this by clicking on here, we have a lot of numbers, but it does something pretty useful, is it keeps the corner numbers to 0, 1, 2, and 3. And that's super convenient, because then if we drop a group node and connect it to the remesh, highlight that. Okay, by default, it selects all the primitives. So give it a name, say, call it pinned, or like this is a node we want to pin. Points we want to pin, I mean, change the group, change the point group type. And here, what we want is we want 0 to 3. So super convenient that it keeps 0, 1, 2, 3 as the corners, because if we hit here in the base group 0-3, it gives you like just the 0 to 3 inclusive. You could also write it this way, and it take each one of the points with the number, with the ID 0, 1, 2, 3, which can, corresponds to our corner points. And that's really simple. Then we bring a Vellum cloth. So Vellum configure cloth. You drop that down, and you just basically, it has 3 inputs here. It has one which is required, which is a geometry. The other one is the constraints in the middle. And the other one would be collision geometries if we were using any colliders. So just connect here your grid over to the Vellum class. And if you highlight that, you see this mesh. Remove the point numbers. So this mesh here, it's basically the geometry of your incoming geometry, in this case, our grid. But it also displays constraints. Constraints are basically other geometry, you can call it, between the different points of your mesh, and that allows the simulation to run, for example, in our case, like a class simulation, which is going to allow you to actually perform a simulation. It's the way the points are connected to each other, and we'll see that in depth a bit later. Then you have to bring down a Vellum solver. And we connect. There again, the solver has the same input nodes. All the nodes from the same family are going to have the same inputs, more or less. Most of the Vellum ones, they have, like, here you have the geometry. The second one is your constraints. And the third one is if you have colliders. So we just connect 3 of them and highlight the Vellum solver. Okay, so we have a grid that has been remeshed to smaller polygons. It has the 4 points that are pinned. We then create a cloth with it, and I've not changed any of the parameters here. And then the solver, the same, I haven't changed anything. If you hit the up arrow on your keyboard, that starts the simulation. So yeah, it's just basically dropping. If we go to the solver, you have a bunch of different parameters here. One of them is forces at the top. We have a forces tab, which gives you gravity force. That just basically adds a force of gravity to any incoming geometry. And as we've seen, if we hit play the simulation again, it just drops. It's not really interesting. If we dive into you double click into the Vellum solver, you get into another level of the solver, which allows you here. We see we have 2 nodes that have already been created by the Vellum solver node. One of them is forces, and that is pretty useful. It allows us to add more forces to the simulation that we had. So far, we have 1 force, which is gravity. If we hit here, pop wind. So pop is like particle operators, I think it means. It basically adds forces and different things to the points. So if we drop down a pop wind and connect it to the forces, it's going to add a wind force to the simulation. So add a wind force to the Vellum solver. By default, the pop wind does not have any sort of noise to it. So if we go to the pop wind parameters and then in the noise tab, amplitude, and say 1, this is just the same as the amplitude in your noise tops or noise chops. It's just the amplitude of the noise. And we go back up 1 level to go back to where we were with the class simulation and run this again. Just run the timeline again. You see that we now have, it's still dropping because of the gravity node, the gravity force, sorry, but we've added a noise force to it. So we get this cloth animation. So earlier we pinned some points, or we selected the 4 corner points because the point here is to have them pinned so that, the cloth doesn't fall all the way. It has 4 points that are going to be fixed in space and not simulated, basically. You have to go back to the Vellum cloth, and here there's a lot of different parameters. Constraint types, a lot of different things, where is it? Sorry, here, pin to animation. This is the one that's going to be useful for us in this case. There again, if we have a drop-down menu here. If we select pinned, which is a group that we created just before, it basically pins those points to an animation. In our case, we don't have an animation on them. They're just static. They haven't moved. So those points are not going to be simulated. If you run the simulation again, you have the same thing. We have some noise on the cloth. We have some gravity on the cloth, but we have 4 points, the 4 corner points that are pinned that don't move. So they keep the, the mesh up, or like they keep the mesh, the simulation in place. Great. So that's another like more concrete use of groups, is to have, create a group on which we have just like one operation which is performed, which in this case is like just pinning the points in the Vellum animation or the Vellum simulation. We could expand a bit on that, for example, and use a group by range. If we connect that between the first group we created and the Vellum cloth node. So we named this group pinned. So in this other group that we've just created here, the group range, we have to keep the same name, pinned. So we type it in here in the group name. And if you come a bit lower here, there's merge method. So either it's going to replace existing, which is the default setting, which would replace the 4 corner points that we had before, but we want to union with existing, which means here we can add more points to that first group we created and have more points be pinned. If you come down to the range filter here, one thing to change also is to change the group type from primitives to points, because we're working with points in our case. And if we change the range filter to say select every 1 point of every 30 points, for example. And you come back here, if you highlight your group node and select it and come back here, you'll see that some of the points are orange. It's actually selected 1 of every 30 points to add them to that group. So we created the group with the 4 corner points, and then we create another group, or like we merge more points into that same pinned group. And when we highlight the Vellum solver, again, you have to reset your timeline. You'll see that when you've been running a timeline, it's this like bluish color, and if you change things, then before your simulation, the timeline will become orange, and that sort of tells you that you have to recache it. So if you go back to the start of your timeline and then run it again, we have a different result now. We see that a lot more points have actually not moved, because we've expanded the group from just being the 4 corners to having a bunch of other random points in them that end up being part of this fixed point group. And if you run it, there's a lot more points that are not being simulated. So, I mean, I don't know if anyone has any questions at this point. We've just basically gone over like a lot of different things and just seen like how to put stuff together in Houdini. There again, like it's pretty easy simulation of making a cloth. Like this, for example, building this sort of thing in TouchDesigner with a real cloth simulation would be way more involved. I mean, you'll have to probably end up building it with like compute shaders or something. In Houdini, like one of the, as I said at the start, like one of the really, I think, at least attractive things for me is that you can get results up and running like really quickly. Here we have this simple thing where we create a grid, remesh it to give it more definition, select the 4 corner points with the group node, just by typing in the point IDs, add some more points onto that with the group range where we just selected, every 30th point in the mesh gets added to this pinned group, and then just without even changing anything on the simulation except for adding the wind here, without changing anything, we've got the simulation of a cloth. So really useful, like really quick to get up and running, and really overall pretty simple. If we check a bit more of the cloth simulation, for example, if you come to the bottom of the parameters on your Vellum cloth node.
Hi, Dominique.
There's this, yes?
With me, I think it's better to insert the break time because the 1 hour is past due. So
Okay.
can I insert break time?
Yeah, no problem. Okay.
Oh, okay. And okay, please finish the good point to experience the cross simulation.
So I finished just this and then we get a break?
Yeah.
Okay. Yeah, so super quickly, if you go back to your Vellum cloth and come to the bottom of the parameters, you have the stretch parameters and the bend. Basically, stretch is how much your cloth or your fabric can stretch. And bend, there again, is the same as like how much your fabric can actually bend, or how much the polygons can bend. So if we lower this number here to something very small and run the simulation again, it tends to have like a more flexible result. And if we go to the stretch one here, we have stiffness, dampening ratio, and then rest length scale. The rest length is basically the distance between each of the points before the simulation. So if you make that just a bit slightly higher, it's going to, by default, as soon as the simulation runs, increase the rest length by 1.1. So make it a bit longer. And you see that by the fact that, as soon as you run it, it sort of crumples up and it gets like, it looks like you have more detail. If you start adding more polygons to that, so we went back to the remesh node and made the target size even smaller and then rerun your simulation, you start getting much more detailed simulations. Yeah, so I guess we can take a break at this point. Up to now, we've just like seen a bunch of different nodes, different things, working with attributes and groups mostly. And we take a break, and after that, I think it could be more interesting to actually build sort of a more concrete example from start to end and see a lot of those concepts put together and make more sense.